Welcome to the debate. Imagine you have two entirely different blueprints to build the city of the future. Blueprint A has absolutely no master plan. You essentially just hand unlimited cash to a bunch of eccentric architects, remove all the zoning laws, and hope they organically build something brilliant, right? Based purely on market demands.
Right, so it's this chaotic, highly capitalized free-for-all.
Exactly. And then, Blueprint B is on the other extreme. It has a strict, millimeter-perfect master plan backed entirely by the state. But you are severely restricted on the actual building materials you're allowed to import.
A highly orchestrated, yet resource-constrained engineering project.
Exactly. And that is the foundational architecture of the 21st century we're looking at today. We are examining the global race for artificial intelligence. And for the university students listening who are about to graduate into this geopolitical landscape, we really need to look past the superficial headlines.
Yeah, this isn't just a competition over who builds the most entertaining chatbot or, the fastest code generator.
Right. It is a strategic battle for economic, military, and political power.
It's the infrastructure of the next global economy. We're talking about who controls the data centers, the industrial automation, the operating systems, and ultimately the supply chains. AI is a technology of supreme national importance because it fundamentally alters business productivity and physical infrastructure.
Which brings us directly to the core of our discussion today. We are looking at the two massive geopolitical powers driving this technology and asking, which organizational structure is actually better suited to win this global AI race? We have the American model, which is fundamentally driven by a decentralized private sector, and we have the Chinese model, driven by highly coordinated state planning. My perspective is that the American ecosystem, fueled by venture capital, organic market dynamics, and an unmatched ability to pull in global talent, is the ultimate engine for foundational AI innovation. You simply cannot centrally plan the future.
And I look at that entirely differently. The Chinese state-coordinated model prioritizes massive industrial capacity and what we call algorithmic efficiency out of sheer necessity. By deeply integrating state goals with corporate drive, China is building a more resilient, physically grounded AI infrastructure. It's a model better suited for long-term technological autonomy, precisely because it isn't beholden to the chaotic whims of the market.
Let's break down the mechanics of the American model first. The term market dynamics gets thrown around a lot, without explaining how it actually functions in AI development.
Yeah, it's a bit of a buzzword.
Totally. But the US strategy relies on this uniquely decentralized pipeline. You have the massive tech giants, Microsoft, Google, Meta, Amazon, providing the raw cloud infrastructure.
The compute.
Right, the compute. Then you have these highly specialized AI research labs like OpenAI and Anthropic, pushing the frontier models. But the glue holding all of this together is venture capital.
And that venture capital is what you see as the primary advantage here?
It is absolutely central because of how VC handles risk. Building foundational AI is incredibly expensive and, frankly, highly uncertain. The VC model works on asymmetric bets. A firm can fund 10 radical experimental AI paradigms.
And most of them fail.
Oh, 9 of them might fail completely, just burning hundreds of millions of dollars. But that 10th one, that one becomes the next OpenAI and completely redefines cognitive science.
Right.
That tolerance for massive, unstructured failure is what allows academic discoveries from places like Stanford or MIT to instantly scale into commercial products. You just cannot replicate that in a centrally planned system. A government trying to meet strict 5-year industrial quotas mathematically cannot justify a 90% failure rate on experimental software architectures.
Well, you're absolutely right that state planners dislike unpredictable failure, but that assumes China's AI ecosystem is just, a group of government bureaucrats pushing buttons, which completely mischaracterizes how their system actually operates.
How so?
State coordination in China does not mean the elimination of fierce market competition.
It certainly dictates the boundaries of that competition, though.
It channels the competition toward national priorities, which is a crucial distinction. If you look at the Chinese domestic landscape, you have tech behemoths like Alibaba, Tencent, Baidu, but you also have incredibly agile startups like DeepSeek, Moonshot AI, Z.AI.
Right, they have their own internal ecosystem.
Exactly. And they are engaged in a brutal, cutthroat fight for market share internally. The difference is the foundational safety net and the ultimate objective. In the US, if an AI startup doesn't show a path to quarterly profitability, what happens? The VC funding evaporates and the servers shut down.
The market corrects.
But in China, Beijing uses targeted state subsidies to de-risk the foundational infrastructure. They ensure that the energy grids, the data centers, the industrial integration pathways, those are fully funded and protected.
But protected to do what? You're describing a system that optimizes for survival. But innovation isn't about mere survival. The source material frames this perfectly as a race between the brains and the bodies of artificial intelligence.
I know the analogy, yeah.
And the US undeniably dominates the brains. We're talking about the frontier large language models, the generative systems, the architectures capable of complex autonomous reasoning.
I understand the brains versus bodies analogy, but I really think it creates a false hierarchy.
Well, let me finish the thought. Because the hierarchy is structural. An advanced generative model can write code, it can synthesize molecular biology, it can act as an autonomous agent. That is the brain.
Right, but
If you don't control that foundational intelligence layer, how much does it really matter if you can build the robotic body? The intelligence is what dictates the value of the physical shell. If the American ecosystem owns the cognitive architecture of the 21st century, the physical factories simply become hardware running American software.
Okay, but that is a very Silicon Valley-centric view of how the global economy works. Software alone does not run a physical economy. You can have the most mathematically sophisticated generative model in the world, sitting on a server in California. But if it isn't deployed into the real world to actually mine resources, accelerate physical manufacturing, or modernize logistics, its geopolitical utility is incredibly limited.
Limited? I mean, it's completely redefining knowledge work globally.
Knowledge work, yes, it's redefining knowledge work. But the global economy runs on physical goods, agriculture, shipping, industrial manufacturing. China's focus is firmly on the body. They are integrating AI directly into industrial automation.
Right, like automated ports and things?
Automated ports, robotic assembly lines, physically modernized supply chains. An incredibly smart API endpoint cannot assemble a smartphone or maneuver a cargo ship. By prioritizing the large-scale industrial deployment of AI, the physical manifestations of the tech, China's turning raw compute into actual international influence and tangible economic output far faster than a company just selling a $20 a month subscription for a chatbot.
I think that severely underestimates how the brain will eventually operate those exact physical systems, though. The decentralized American model naturally attracts the world's top specialists precisely because it isn't tethered to a rigid industrial policy. If a researcher from Europe wants to experiment with a completely new neural network architecture, they come to American labs.
Because there's no central committee.
Exactly. There's no one telling them their research must apply to automated port with just 6 bytes by 28. Spontaneity is what birthed the deep learning revolution.
You praise spontaneity, but spontaneity is inherently fragile. You are talking about an ecosystem that relies entirely on market whims.
I'd call it market efficiency.
But what happens when the venture capital dries up because interest rates go up? Or what happens if consumer interest in generative AI plateaus before it actually becomes profitable?
Then the market corrects and reallocates capital to whatever is actually working. That's a feature, not a bug.
It's a feature for investors, sure, but it's a massive vulnerability for national security and geopolitical strategy. Critical research can stall out overnight in the US if the market gets spooked. State coordination provides a shock absorber.
A shock absorber for what, exactly?
For the long term, the Chinese government has laid out a multi-decade plan to expand intelligence systems and achieve technological autonomy. That means guaranteed sustained investment in fundamental AI research, regardless of short-term profitability. If the global economy crashes tomorrow, American VC funding for AI startups might vanish. China's state-backed AI industrial parks will still be building robots the next morning.
It's a systemic approach designed to weather the exact kind of storms that a purely profit-driven ecosystem retreats from.
Okay, well, if we are talking about vulnerabilities and weathering storms, we have to address the elephant in the room. You're talking about resilience as if the Chinese ecosystem operates in a vacuum.
Obviously, it doesn't.
Right, it doesn't. And it suffers from a fatal physical bottleneck that American policy currently controls. I'm talking about the semiconductor conflict.
The chip export controls.
Exactly. The United States holds massive entrenched advantages in semiconductor design and, through its allies, manufacturing. You just cannot train a frontier AI model without linking together tens of thousands of highly advanced processors, specifically GPUs.
True.
The physics of computation are absolute.
Right now, China does not have free access to the most powerful processors on the international market due to these export restrictions. So you can have all the state planning, resilience, and industrial parks you want. If you physically cannot acquire the silicon required to compute the mathematics of advanced AI, your progress is hard-capped. The American ecosystem controls the silicon speed limit.
There is absolutely no denying that the restriction on advanced GPUs is the most severe friction point in China's AI development. It is a massive constraint. But I look at the result of that constraint entirely differently. The irony of the American export controls is that they are actively forcing the Chinese ecosystem to become radically more efficient. It's effectively accelerating their independence.
Wait, how does being denied the best hardware accelerate your progress? That defies basic logic.
Because it completely changes the engineering philosophy. In the United States, when an AI model is too slow or requires too much memory, what's the default Silicon Valley solution?
You scale up.
Right, you just throw more compute at it. Buy another 10,000 NVIDIA chips, build a bigger data center. It's a brute force approach powered by unlimited access to hardware. Chinese researchers do not have that luxury.
So they have to optimize.
Aggressively, because they have to run models on older, less powerful, or domestically produced chips. They are forced to innovate in algorithmic efficiency.
So you're talking about model compression. Let's actually break that down for the university students listening, because the mechanics here are fascinating. What does it actually mean to make a model more efficient?
Okay, think of a neural network like a massive, dense web of billions of connections. When you train a model, a lot of those connections end up being mathematically redundant.
Right, they aren't all strictly necessary.
Exactly. So Chinese engineers are essentially performing mathematical surgery. They use techniques like pruning, where they systematically identify and cut millions of parameters that just don't significantly impact the model's intelligence.
And quantization too, right?
Yes! Quantization, which basically lowers the mathematical precision of the calculations, just enough to save massive amounts of memory, without losing the core reasoning capabilities.
So in simple terms, they are essentially shrinking a massive model so it can squeeze onto a weaker microchip.
Precisely. They're doing more with less. And they heavily utilize open source frameworks to bypass proprietary bottlenecks. By being forced into model compression, they're developing leaner architectures. We are already seeing models coming out of China that perform comparably to top-tier American models, but require a fraction of the compute power to run.
That's necessity breeding superior engineering.
Exactly. When you combine forced algorithmic efficiency with state-backed energy subsidies, you get an ecosystem that is highly resilient precisely because it had to adapt to severe hardware constraints.
I respect the engineering ingenuity of model compression. I really do. Pruning and quantization are incredibly difficult computer science problems. But you're describing a workaround to a fundamental deficit.
A very effective workaround.
Sure, but even if you compress a model perfectly, the US labs are taking those exact same algorithmic advancements and running them on hardware that is 2 or 3 generations ahead.
But the scaling laws of AI might not last forever. We might hit a wall.
Perhaps, but let's look at how this technology actually scales globally right now. The American model doesn't just rely on brute force computing power. It relies on the organic formation of technological alliances.
Meaning what exactly?
Well, because the US ecosystem is open, decentralized, and driven by private capital, it naturally integrates across borders. A startup in Silicon Valley might be using an open source tool developed by a researcher in Paris, trained on cloud infrastructure that spans 3 continents, funded by capital from Tokyo.
Okay, I see your point.
It creates a deeply entrenched global dependency on American foundational systems.
And I think the Chinese model inherently isolates itself.
Isolates itself? How?
A state-directed system, by definition, prioritizes strict national autonomy. When your core objective is to ensure that government maintains absolute control over the technology and the data, you build a walled garden.
A highly efficient walled garden, as we discussed.
True, but it struggles to become the foundational layer for the global economy. Countries and international corporations are hesitant to plug their entire societal infrastructure into a closed system, especially one explicitly directed by the state apparatus of a geopolitical rival. The American model wins because it invites the world to build on top of it.
I think you're conflating the export of consumer software with the export of foundational infrastructure, though.
Explain that.
Yes. A European startup is more likely to use an American API for their language model, but you are ignoring the vast majority of the global economy. China is deploying its technology by exporting the physical tools of modernization to the developing world.
Through initiatives like the Belt and Road?
Exactly, but upgraded for the AI era. We're talking about the global south, emerging markets in Africa, Latin America, parts of Asia. These are economies that simply cannot afford the premium prices of American generative systems running on top-tier cloud platforms.
Right, the economics don't work for them.
They don't. What they desperately need is physical automation. They need smart logistics for their railways, automated mining equipment, highly optimized agricultural drones. China is providing those integrated physical systems at highly subsidized, competitive prices.
So they're building the physical AI infrastructure.
Exactly. They are actively transforming their algorithmic efficiency into international influence in the developing world. They don't need those countries to use a Chinese chatbot. They just need them to rely on Chinese automated ports and telecommunications routing.
That is a very pragmatic strategy, I'll admit. But it brings me right back to the mechanism of innovation itself. You're describing a system that is incredibly effective at optimizing current technologies and applying them to existing industries.
Which is massively important.
It is. But technological supremacy isn't won by perfectly optimizing the current paradigm. It's won by discovering the next one.
And you think central planning prevents that discovery?
I think it fundamentally discourages it. Let's look at the leading companies driving the Chinese ecosystem: Alibaba, Tencent, Baidu, DeepSeek. They are undeniably capable.
World class, really.
But they operate in an environment where state subsidies and integration with government priorities dictate the boundaries of their ambition. If your mandate is to optimize industrial supply chains, well, you will build world-class supply chain AI.
Right.
But in the United States, venture capital allows for unstructured exploration. The breakthrough of the transformer model, the architecture underlying literally all modern generative AI, that wasn't part of a national industrial plan to automate factories.
No, it was a research breakthrough.
It was a theoretical leap in cognitive science and natural language processing. I am assuming that if you are entirely focused on solving immediate industrial bottlenecks or adhering to a state's long-term master plan, you risk entirely missing a paradigm shift.
But you are assuming the next theoretical leap will only come from unstructured wandering.
The American ecosystem's tolerance for radical, unstructured experimentation, for funding things that seem like academic novelties until they suddenly alter human history, is what birthed the current AI revolution. A master plan is only as good as the technology available when the plan was written.
That assumes the physics of computation will always reward unstructured software exploration, though. What happens when simply making a neural network larger no longer yields proportional gains in intelligence?
The scaling wall.
Yes. Many experts believe we are approaching a wall where brute force scaling simply runs out of data, or frankly, requires too much electricity. This is where the Chinese model's internal environment becomes uniquely powerful.
Because of their focus on efficiency?
Exactly. Because companies like Huawei and Moonshot AI are already conditioned to fight for architectural superiority rather than just relying on scaling up server farms. They are philosophically better positioned for an era of AI research that requires fundamental breakthroughs in efficiency.
So it's a dual-engine system.
Right. The state planning ensures the foundational resources, the energy, the data access, the industrial integration are guaranteed.
while the fierce internal corporate competition drives the software optimization.
I hear you. The combination of state-guaranteed resources and forced architectural efficiency is certainly formidable. But as we look towards synthesizing this, I think it's crucial we acknowledge a vital piece of context from the material.
The blending of the two models?
Right. This clean division we've drawn between the American brains and the Chinese bodies, or between private spontaneity and state-directed efficiency, it's a great framework for understanding their different philosophies, but it isn't entirely rigid in practice.
No, it's not absolute at all. It's about where the center of gravity lies. The reality is highly blended. I mean, the United States is obviously pouring billions into domestic chip manufacturing through the CHIPS Act.
Which is effectively its own form of state industrial policy.
Exactly. And they are heavily investing in robotics and military applications.
Just as China is pouring massive resources into developing frontier large language models and advanced cloud computing, trying desperately to close the gap in the brains of the operation, neither side is ignoring the other's strengths.
Precisely. But the true difference, the crux of our entire debate today, remains how each power fundamentally organizes its society's resources, handles risk, and attempts to translate raw computational power into lasting geopolitical influence.
Right. And to summarize where I stand on that fundamental organization, I remain completely convinced that the American decentralized model is a superior engine. The combination of private innovation, the unparalleled risk tolerance of venture capital, and a cultural magnetism for global talent, it just creates a dynamic ecosystem.
A very fluid one, yes.
The ability to spontaneously connect university research with instant capital and open markets allows for paradigm-shifting breakthroughs. It is an architecture of innovation that is simply too fluid, too adaptable, and too globally integrated to be outpaced by central planning.
And my summary perspective is that the Chinese model's synergy of long-term state planning, massive industrial capacity, and forced algorithmic efficiency creates a far more robust and physically grounded framework.
By focusing on the real world.
Yes. By focusing on deploying AI into real-world automation, and by turning semiconductor restrictions into a catalyst for leaner, superior software engineering, China is building an AI infrastructure that doesn't just live in the cloud, it is designed to physically integrate with and eventually run the physical global economy.
Well, for any of the university students stepping into this rapidly changing landscape, whether you're studying computer science, international relations, or economics, this is the underlying machinery of the world you are inheriting.
It will undoubtedly be the defining strategic rivalry of this century.
Absolutely. The geopolitical reality of the coming decades will be shaped by the friction between these two approaches. We've barely scratched the surface here. There is so much more to explore in this material regarding data privacy laws, supply chain logistics, and intellectual property.
There really is.
So as you watch this technology reshape the global economy, ask yourself the fundamental question: are we ultimately better off letting independent developers spontaneously build the future, or does surviving the century require a master plan? Thank you for joining us on The Debate.